All right. Hi, everyone. Thank you for coming to my session. I know everybody's tired. It was a long day. I hope everybody learned something new today. And I'm going to cover the Azure Cosmos DB with you today. I'm going to try to share some of the tips and tricks I learned from the projects I worked on. So our agenda is going to be, we are going to start with the physical partitions. We are going to move to the connection types. We are going to look at the SDK types and some of the tips I can give you out there. There's a caching option. It might be useful for you, and it might actually save you a lot of money if you are reading the same data again and again. And we will end the session with the indexing. Since Cosmos DB is a database at the end, we are going to check out the indexing too. So before I start, I guess let me speak about myself. My name is Hasan Savran, and I am from United States. I live in Cleveland, Ohio. And I'm a data platform MVP. That's my 6 years, and I'm proud and very happy to be a member of the group. I'm the developer for the Cosmos DB, the SQL Studio. I hope some of you are actually using it out there. I'm the only developer out there right now. But we have a good number of users. And if you have any kind of feedback, please let me know later. I'll be more than happy to kind of share. If we will have time at the end, I can maybe demo that for you. Rather than that, if you will have any questions later, please follow me from the LinkedIn or the Twitter, or X, I guess now. I will be more than happy to answer any of your questions out there later. So let's talk about the physical partition. Well, when we say physical partition, really, it's the Cosmos DB server. And I guess physical partition is a fancy name. So we have logical partitions, which you have some rights to change. In physical partition, there's not that much you can really do. But it's important to know these two numbers you see here. So Cosmos DB, I'm really kind of comparing that to maybe like a restaurant here. So when you open like one server, it's like almost like you open your restaurant, and it gives you two numbers. One is the 50 gig, that's the storage limit that one server can actually handle, and also 10,000 request units. That is the horsepower that actually it can give you per second. So in here, when you start to actually have more traffic and more storage, for example, if you're going to start to get close to the 50 gig data here, or you're going to have a web application which is very busy, you're going to get close to 10,000. Rather than like a SQL server, which you might need to create maybe another floor on your current restaurant or try to make it bigger, well, Cosmos DB works a different way. So in Cosmos DB, it franchises it. So you start to open different restaurants in other places. So that's how you don't have any limits with the storage or the horsepower, because if you need it, it will give you another restaurant or another server somewhere else. So that is pretty important to know, because the data you see here in the different kind of data servers are not replicated data. That is distributed data. In other case, each of them has different data. So it's very important for you to kind of know where the data is, so you can send that request to only one server, not all the servers you have. So that is pretty important. So let's actually look at one example here. Let's say we are saving orders, and we pick the customer ID as our partition key, and looks like we have 202 gig of data. So, and also we have the 10,000 request units. So now, by just looking at the numbers, you can easily create a diagram. We have 202 gig, so we are kind of handling like 5 servers here. Also, we know the 10,000 request units, that's what we are paying for. That means that 10,000 is going to get divided by the number of servers you have. So that's really, we can kind of create this diagram without knowing anything else by just knowing those two numbers, 50 gig and 10,000 per server. Also, it looks like we did a good job balancing the storage, because the storage per server looks very similar to each other, and customer ID looks like that's a great partition key. And 10,000 request units per second is giving us 500 query, like all the numbers you see out there per second. So that's pretty busy application. And most of the queries we have looks like using the customer ID. So it looks like our developer was learning a lot about the partition keys, so they did a good job. So probably the developer is feeling really good in this case. Manager should be happy, and everything is working fine. Unfortunately, that's not the only, I guess, the problem you might have. So you might be in this case, everything might be working fine, and you might say that, okay, let's try to use the Cosmos DB a little bit more, maybe for different projects. Maybe we have the orders container right now. A new project comes up, and right now, as you can see, you need the customer ID. Everything is coming up with the customer ID. Maybe you want to see all the products per order. That means you are going to have another kind of project coming up, and we are going to use the product ID rather than the customer ID. So in that case, we have a problem here, because whenever we start to actually run this query in the same container, what's going to actually happen here is we are going to be in trouble with this project and the other project, because, well, we are not using the right partition key for the orders collection. Then, this is going to start to actually cost a lot of money, and probably developer who created this one, now, if you do this in, for example, SQL Server, you can just put an index on the customer ID. It might give you an okay, performance. But in here, you're in trouble, because you are using a collection here, which is actually developed specifically for the orders. So when this happens, when you get the bill, you're going to probably, surprised about it, because there's a lot going on here. And probably this actually broke the other project I showed you before. Well, because probably you don't have enough request units for the orders to write, and you might need to kind of change your request units threshold to a higher number here. So what do we do here? That's one of the most, I guess, the questions I get and most problems happens usually. We have the change feed function in Cosmos DB. In our case, what we are going to actually do here is, so we already have the orders collection. Our partition key is the customer ID. So that one is working fine. The one that we are having problem is the different partition key, which is the product ID. So in this case, what we are going to do, we are going to create another collection. Let's call that orders under product. So all we need to do here is we need to sync the data. We are really duplicating the data in two places here. And depending what we are going to try to do, we can go and hit the orders collection and get our data, or we go and get the data from the orders underscore product. And change feed is going to be able to duplicate our data automatically here. So the change feed is very close to the CDC in SQL Server, if you are familiar with that. Whenever data changes, change feed tracks that, and change feed is available in the NoSQL API, Cassandra API, Mongo API, and Gremlin API. You can actually get these changes in many ways. I prefer the Azure function because it's already in cloud, Azure Cosmos DB in cloud, so it's much easier to set up with the Azure function. But if you want, you can write an SDK, and you can do that with your own code if you like. So whenever data is going to change, in our case, a new order is going to come in, and Azure function is going to get triggered. In that case, right now, you have the order ID, so you can actually get all the information and take that information and do anything you like. In our case, we are going to duplicate that data in a different collection. So in our case, but don't forget we have that insert charge out there, so that's not going to be free. That insert, every time you're going to order something that orders under product, that's going to be an insert charge. So you kind of need to plan for that, or it can be a surprise for later. So in our case, if we have the customer ID, we are going to go and hit the orders. And if we have the product ID, we are going to go and hit the orders under product. This might be the cheapest way to fix this problem, because we are just creating a view in here, really, and you are fixing the problem by storage. And in cloud, storage is much cheaper. So if you can fix the problem with the cheaper in here, that will be the best way to handle this problem. Also, we have a point read function in Cosmos DB. Point read is the fastest and cheapest way to read data. You can read the data by point read or query. When you read the data by the query, you are actually running an execution plan. That's why when you look at the RU charge here, it's almost like 3 times more than point read. But point read, you must have the partition key and the document ID for it to work. In the query, it's highly recommended to have the partition key, but you don't have to. And you don't have to do anything with the ID. So if you have a 1 kilobyte data model, that will cost you 1 RU with point read, and it will cost at least 2.3 or more in the query. So whenever you are architecting your project, you want to be sure that even you don't use it, you want to be sure that you have the partition key and ID available in somewhere. Maybe you hide it somewhere under the web application. Maybe you have a grid out there, and you can just hide partition key and include ID in under each row. When somebody clicks on that, you can easily go and actually trigger the point read rather than the query. That will make things much cheaper and affordable in Cosmos DB. So the only, I guess you don't see the point read that much because there's no way to run the point reads in Azure Portal right now. So you can run the query from anywhere, but the point read, you have to run that from the SDK. So that's why you don't probably see it that much, but it's available out there, and you can do that as long as you have the partition key and include ID is available. Next, we are going to look at the connections. So there are many different ways to actually connect Cosmos DB. The most basic one and most common one is the gateway mode. Gateway mode is available in SDK 2 and 3, and it's default connection for the SDK 2. So we really there's a server between your application and the Cosmos DB, and that creates like a one network hub, but it makes things a little bit easier, especially if you have like firewall, strict firewall rules. You don't need to worry about trying to open the IP range or the ports here, because everything in the gateway mode, as you can see, it uses the HTTPS and DNS endpoint, so it should be pretty easy to call and get the data in this way without kind of going to your IT department and try to change the IP addresses or the firewall settings. So there are a couple of things that you need to know here. First of all, that server is free, but because of that, you share that server with other Azure Cosmos DB customers. Cosmos DB is available to kind of figure out who's, what resources that server is using, so you don't have to worry about it, but that's something to kind of know. Also, in this case, let's say we have two different companies. One is using the Mongo API, other one is using the SQL API. They are using the same server here. Just like the web browser, whenever you try to open ports or to open connections to the web applications, there's a limit, like 50 connections. If you want, or your application is really busy, you can actually override that number for Cosmos DB. So in that case, all you have to do here is in the documents clients, connection policy, and the max connection limit, it can go up to 1,000, but I don't recommend going to the 1,000 because that might be too much depending on the resources of your server, but you can easily change the connections in the same time connections to Cosmos DB by changing that. Second one, which is the recommended way, is the direct way. So in the direct connection, we are using the TCP and we are using TLS. So probably you need to go to your IT department and change the settings for your firewall for this, or to open the ports for it to work. In here, as you can see, we don't have a network hub anymore, and everything should be much faster. But in the same time, don't forget to have some good resources for your SDK wherever it lies, because right now, SDK is the one which needs to figure out which database has what data. Before, the gateway server was the one which is handling that. Now that responsibility is going to be your SDKs. And this is available only in .NET and Java for now. If you are using the SDK 2, you can easily change your connection mode to direct mode by just overriding the Cosmos client easily. We have one more, which is the dedicated gateway mode. I think that kind of explains what it is. That's your server. You are not sharing that. So you might say that, well, why do I need that? Because you are not, actually sharing that. That means that you have to actually pay for it. And depending on your application's traffic, you have three options. You have small, medium, and large. So in this case, you are not sharing the server with anyone. And by doing that, really Cosmos DB actually gives you some more options or features to use. The first option actually they gave with this is the caching. So if your application is reading the same data again and again, or your data doesn't change that much, well, by doing the caching, you can actually save a lot of request units, which means money. So in this case, as you can see, this works only in session and eventual consensus levels. You can easily overwrite your transaction, so your database doesn't have to be like, for example, session consistency. You can run your query in session in that case. So in here, we have an application, try to read or point read the data. It goes to our server, dedicated server, and dedicated server gets the data back, and you pay some kind of request units for that X number. When you send the same thing again next time, well, this time it costs you 0 request units. So as I said before, that can save a lot of money if you are reading the same data or your data doesn't change that much. So how do we make that work? First of all, your SDK needs to be 3.2.1 or later. And you must need to first go and configure the dedicated gateway server. So I'm not sure if you can see it here, but there is, right here you have to go and actually pick the size of the server you need. It's going to be low, medium, or high. Pick it wisely because you cannot change it later. You can drop it and create a new one, but just pick it wisely because you cannot make a small one medium later, for example. When your server becomes available, then under the keys, you will see 2 more connection strings, and those will be the dedicated connection strings for your server. So all you have to do is just take that and put it in your application to use that. So if you look at the code, how that thing actually works here, as you can see, if you're in SDK2 or SDK3, in SDK3's connection mode, the default one is the direct. So you have to actually override that and make that gateway first. Then, in our request options, as you can see, I'm not sure what your database consistency, but I want to be sure that this is going to get cached. So you can make the session or eventual. That's one of the requirements for caching. And also, you have to tell how long this needs to get cached. And in my case, it's 30 minutes. I'm going to cache this data. So in the next 30 minutes, same query, whatever I'm passing here is not going to cost me any money from the Cosmos DB. Bypass integrated cache is new. I believe it's in preview. I'm not sure public or private preview, but by just making that true, if something is cached, you are really forcing to go and hit the database even it's cached. In some cases, you can use that. So in my case, as you can see, my first time, I returned 592 posts in here, and it cost me 32.25 request units. Next time, when I run it, well, next 30 minutes, that's going to be 0. So as you can see, you can really save a good number of request units here. Next one is, let's talk about the Cosmos DB SDKs. So as I said before, we have the data, and data is distributed all over the place. Now, if you have any kind of aggregation, any kind of order by, or if you are trying to find maybe average of the ages, for example, well, as I said before, your data is distributed. So the server 1 has no idea what server 2 has. So how are you going to group by? How are you going to order by in here? So all the pressure here actually goes to your SDKs, because SDK is the central place all that data actually comes in. So in my case, I look at the select top 10, and I order by the view count. So all the data is going to come into my SDK, and SDK is the one which is going to actually make all that aggregation and give you the data. In this case, I think there are like 10 servers here. You're actually receiving, well, 100 documents here, but SDK is going to display only 10. So all that job that SDK is going to do, it can be, expensive. So you want to be sure that you have enough resources wherever the SDK actually lives, because there's going to be all kind of for each loops and all kind of memory is going to need to make all this work. So if you look at actually this is the JavaScript SDK from the Cosmos DB. As you can see, we have the query info data out there, and it actually senses what you have. So in our case, this is our query, and that query is getting rewritten by the SDK. To make it easy when the data comes back, it can make it easy to kind of order by or find the data it needs. So as you can see, it senses I have a select top 10 here, and also I have an order by. So depending what you have out there, SDK actually rewrites your query. If you are using the .NET SDK, there are a couple of things you really need to know. The first one, you want to be sure that your application is in 64-bit. Whenever you create a new project, usually it goes with 32-bit or any CPU. You want to be sure that it's going to be 64-bit, because that file you see out there, the service interrupt.dll, is available only in 64-bit solutions. So that one is pretty important, because whenever you run a query, you kind of need to create a query plan. And if you have the service interrupt DLL, it can do that locally. So you are really saving one request to Cosmos DB for that. So if you have in 32-bit, it needs to call Cosmos DB for that. Next one is the default trace listener. You want to be sure that you disable that in production because it can do kind of bottlenecks in the production. Also, the garbage collection, you want to be sure that you use the server mode, not the workstation mode. That can create problems too for you. And if you are doing any kind of testing in Cosmos DB, and if your request unit is higher, well, the website says 50,000, but I will recommend 40,000 or higher. You want to probably use multiple servers or the multiple to actually hit the Cosmos DB, because one computer is not going to be able to handle that 40, 50,000 request units or higher. You are going to end up with 429s or all kind of problems when Cosmos DB can actually handle it. Those errors actually happens because of your server, not the Cosmos DB. Next one, we are going to look at the Stream API here. Stream API is available in SDK3, and it makes kind of the job much easier if you compare to SDK2 here. For example, in SDK2, we have the serialize and deserialize every time we get data from the Cosmos DB. So in the SDK3, if you use the Stream API, you don't need to do like this 2 steps anymore, and you get the data and just return it as it is to your client. So if you look at the details a little bit here, for example, that's the SDK2, and most of the people are using this. This works if you have the partition key or if you don't have the partition key. This works for both. As you can see, we are actually running this query here, and every time it looks like we are returning lists of sales. So every time you create that sale object, really, you are doing the serialization here. And when you are done with this, you need to return this probably as a JSON object. So that's the deserialization you need to do. So that's like 2 steps you are doing every time. In the stream, we don't have to do that anymore. But I guess the catch here is you must have the partition key. So you cannot have the cross-partition queries with stream. But if you have the partition key, this makes things much easier here, because as you can see, we are taking the data as JSON and returning as JSON here. So everything is much faster and easier. Next one is document client. Document client is really the door, I guess, going to the Cosmos DB. You want to be sure that you are going to use the singleton whenever you create the document client. The last thing you want to do is you want to create the document client every time before you call Cosmos DB. Main reason for that is, let's actually see what happens when you initialize the document client. The first thing is going to happen is it's going to call the Cosmos DB, and it's going to get your account information. Then it's going to create another request. It's going to get all your container information. After you pick the container, which container you want to get the data from, then it's going to go and figure out which partitions and the routings is happening in that container. So that's 3 requests. Your 4th one is going to be the query. So the last thing you want to do is you want to do this again and again and declare the document client every time. So just use a singleton. That will save you actually a lot of headaches if you use that. So actually, this is a great place to talk about the consistency levels in Cosmos DB. So when this happens, you have the document client ready. We know how many containers we have. Now, the consistency level is going to actually figure out where the data is going to come from. So we have a replica set in every server. That means that our data is available in 4 different locations. So depending on the consistency level, we might need to hit the leader or the followers. So that's the place that actually is going to decide where the data is going to come from each servers here. Next one is metadata requests. So this happens if you are actually creating, updating, getting the list of the containers, databases. You are not really doing any kind of operations, but you are really getting information about your containers, databases. So there are some limits here. Those are hard level out there you cannot change. So if you are doing this a lot, you kind of need to know those numbers. For example, you cannot create 100 containers or database per minute. Also, we have the request unit to charge 240. That's a system reserved. Doesn't matter you have 10,000, 20,000 request units. That number is always the same. So if you are reading a lot about your containers, databases, maybe you put them in a drop-down out there, or you are creating maybe like dynamically containers, those numbers are important to know because they will be, like limit for you. The best thing I can suggest here is, especially for reading, just cache those information. They shouldn't change that much, so you don't have to go and get them again and again from the Cosmos DB. And those are the metadata calls for this limits here, you see. Next one is optimizing the bandwidth. So especially when you are inserting data or updating data, usually you take the whole object, your data model, or you send it to Cosmos DB. You might be changing maybe only one property on that maybe big data model, which is fine, but what happens is when your request is completed, Cosmos DB returns that back to you in the response object. Most of the people, really, they don't really need that object. So your data model can be large. The last thing you want is your response packages, gonna be large. In this case, what we can do here is we can force Cosmos DB to not attach your request object to the response. So the things will go much more smoother because request object is gonna go and Cosmos DB is gonna give you only what happens is gonna be 200, 400, whatever you are trying to do with the HTTP code, rather than all the object you just send to Cosmos DB. So to make that work, all you have to change is actually this property here, named enable content response on write. And you can make this especially on the bulk load too, if you are doing it. That's the last thing you want to do in the bulk load. So you can easily make this false, and you can do this in transaction level or database level if you like. And that will actually help your packages to go much faster because you don't have to send and get that same data again and again. Next one is the partial document updates. As I said before, when you update something, in older days, you had to send the whole data model. So if you are maybe changing the property, I don't know, let's say you are just updating the address from something to another address, you have to send the whole data model. In this case, you can only send what you want to change to the Cosmos DB. That makes the packages much smaller, so things will work faster. But this is not really going to, save you any kind of request units. This is mostly for the developer to kind of make things much easier in the developer side. Because if you really think about it, in Cosmos side, it's going to do the exactly same thing. It's going to open the object, update it, and send it back to you. So this is really mostly for the developer. You can combine multiple operations with this. You can add a filter, which is very useful in some cases. I will have a demo for that one in a little bit. And it supports all the conflicts, if it happens. It's same the conflict resolution supports here. And if you are doing any kind of transactional batch, especially, it's very useful for that too, rather than sending the whole object, you can just send partial document. So those are the operations you see here. You can add, set, replace, remove. Increment is an interesting one. For example, if you are going to change the number of orders, maybe it's 1, you can just increase by 1, or you can decrease by -1. So you can easily do that. Or if you want to change a property from one location to other location, you can use the move for that too. So let's see this actually in action. The first one here is a simple one. So as you can see, I am creating a list of patch operations here. And I am adding the sale date to my data model, and I am removing the original sales date. So that's all I'm sending to Cosmos DB. I'm not sending anything else. But for this thing to work, Cosmos DB is going to require from me the document ID and also the partition key. So those two are important and required for partial update to work. The next one, which I talk about the filter. So in this case, what I'm doing here is I am still passing my ID and my partition key, and I am adding a new property named audit. And audit is true only if the number of items are larger than 5. So that will actually go through if that filter is true. So that's very useful. In some cases, you can actually add and remove things like that very easily by using the partial update. Next one is indexing. So indexing is important. We have 3 types of indexing mode. And when we talk about the indexing mode, in Cosmos DB, we have 1 index file and 1 data file. Data file is where our data is, and index is all the indexes you create for it. So really, the indexing mode is controlling the consistency level between those two files. You should always use the consistent, because that means that your data is always matching your index file. So if data changes, immediately index changes. Lazy is available out there, but many people might use that because lazy is cheaper than the consistent. But it can give you a lot of headaches and a lot of problems, because by saying lazy, you are really saying its data file eventually matches the index file, which means index file might not have the same data with your data file. So you might create all kind of problems, and you might not know why you don't see the right data and other stuff. Lazy is really not a good option for anything, really, I can think of. So if you're using lazy, just change it immediately. And none, that means we don't have any indexes. That can be useful, especially if that's the first time you are pushing the data to the Cosmos DB and you don't know what should get indexed yet. The last thing you want is, index the whole thing, because when you actually open a new collection, everything is getting indexed in Cosmos DB. So probably you're going to go back and exclude stuff anyway, so it's much easier to keep everything in none. Also, it can be useful if you are using Cosmos DB almost like a Redis. You have a key and you have a value. Your key is usually going to be the partition key, and probably you don't need to index the value in that case. So it can be none, and that will actually make things much faster because, well, if you are none, that means that you don't need the index file. Your inserts, updates will be much faster because it doesn't need to sync all the data in the same time. So we have 4 types of indexes in Cosmos DB. Range index is the most common one, and it really kind of handles most of the operations in Cosmos DB. Composite index is a good one. If you have a lot of data and your workloads is maybe having many filters, composite index can really save you a lot of request units. And also, if you have an order by, and if you want to order by with multiple properties, you must have the composite index. If you don't have it, it won't let you do that. Geospatial indexes are available, and those are only for the geospatial data if you have. And geospatial data will not get indexed automatically like the others. So it's going to be your responsibility to create those geospatial indexes if you have any data. Vector indexes are the new ones, just came up on the NoSQL API, and they are useful for the vector distance system function if you are using it. Currently, that's in preview mode. It looks very promising, and I'm really excited about that one. You can kind of create all kind of dimensions. So right now, everything is depending on the GPT model you use. You can actually create custom dimensions with this and change the dimensions if you like. So the next slide is going to be about the composite indexes, because composite indexes can save you a lot of request units if you use them in the right way. But there are a lot of catches out there. For example, composite index can optimize only one single range filter. And that range filter has to be the last filter in the where clause. So you might think that you are using a composite index, but you may not, because the way that you are querying the data. For example, let's look at these examples. So it looks like we have a composite index for the name and the age. So the first 4 rows is using it fine, because as you can see, the name and age is actually ordered in the right way. And we have one range filter, which is looking the age is larger than 18. That's the last one, so which is good with the composite index. So those are working fine. But if you look at the one in the 5th one, it looks like we have the same composite index, but this one does not want to work because the C name we are saying is not equal to John. So in that case, we have almost like 2 range filters here. So this is not going to work, and you are not going to be able to use that composite index. Then we have last 3 ones here. Looks like we actually have 3 filters this time. The first one works fine because everything is in order, and the range filter is the last one. But if you look at the one in the middle, this one doesn't want to work because the range filter is in the middle. And because of that, Cosmos DB is not going to use the composite index. So there's all kind of details here. You want to be sure that just because you have the composite index doesn't mean that you're actually using it. You just want to really see it's matching your signature of the composite index. To fix that problem, as you can see in the last row, actually I have 2 composite indexes. that actually fixes the problem because I am actually doing it in different properties here. So you can easily fix that like that. When it comes to the modify indexes, so if you are using SQL Server and going to the NoSQL database, and usually in the relational database, you create a table, and it's your responsibility to kind of figure out which columns should be indexed. And nothing is getting auto-indexed. In Cosmos DB, when you create a collection, everything is getting indexed. And this included paths, as you can see, this asterisk is actually controlling that. So that means good because that's a no schema database. So if you are going to have more properties coming up later, those will be automatically indexed as you add them later, so which is good. But I guess my suggestion is whenever you are ready, your application is working fine in production, just go back and look at all your where clauses and figure out which paths you are not using at all. For example, you might have a description and you have a chunk of data in it. That's the last thing you want to probably put an index on it because at the end, if you're going to do the indexing for everything you have, your index file potentially can get larger than data file. That means all your inserts, updates is going to get much slower and much expensive because it has to go and actually index everything in a different file. So you want to be sure that you're going to exclude whatever you are not using out there. Also, you might have 15, 20, 25 servers. So whenever you try to update your indexes, the last thing you want to do is you want to change your indexes just like SQL Server. Usually, you create one index. When it's done, you go maybe create another one. In Cosmos DB, you want to all do them together because, well, indexing is kind of like expensive in Cosmos DB because if you have 20 servers, that means you have to index 20 servers. And that can take time. For example, if you're a web application, let's say you have 1,000 request units per second. And your web application is using maybe 800 every second, so you have like 200 left. Cosmos DB will use that 200 to actually complete the indexes. So potentially that can take days to actually complete that indexes, depending how much resources you have. That's why, yeah, it's free, but you are really kind of paying for it in some way. So it's important to, I guess, change all your indexes in the same time. Throughput, that's the one that you actually pick how much request units you are going to need from the Cosmos DB. And we have 3 options. And the best way to actually explain this to you, let's say we are actually throwing a pizza party here, right? When you pick the provision, you know that how many people are coming, so you can order exactly how much pizza you need. So that's really the provision. You know the traffic, you know how many people are coming to your application, and you request that much request unit from the Cosmos DB. If you know the number, that's a great option. I like the auto-scale option because in the auto-scale option, you are, rather than, I guess, giving number of the pizzas, you are really giving a budget to Cosmos DB. You say that, what, this much I can afford, and as people comes in or they don't come in, you order the pizza for me. So you don't have to worry about what's really happening. For example, tomorrow might be like a big day for you. You are going to actually have a great, big sale. People are going to jump into your application. If you have the auto scale, you can easily kind of say that, okay, I want the 10,000 request units, but today you are only using 1,000. So the Cosmos DB will be responsible to scale up and scale down application as people comes and goes in. Serverless is a great option, especially in dev, QA, or if you have any kind of Azure functions out there. Maybe they run once or twice a day. In the serverless, really, I guess if you compare the pizza party, that will be like you sell the pizza per slice, really. So what's really happening here is you buy, let's say, 1 million request units per month, and you use it, and the Cosmos DB subtract that from 1 million every time you use. So it can be really a cost-saving option if your application is not really demanded all the time. Also, I'm sure most of you come here to kind of learn some way to kind of save some money with the Cosmos DB bill. Without changing any kind of code or any kind of knowledge, I can recommend this coupon for you. So Cosmos DB has a reserve capacity. And if you are using 1 million and less request units for your application, if you do 1 year reserved, they give you 20% off. If you do 3 years, that gives you 30% off without changing any kind of code or anything like that. So if you are sure you are going to use the Cosmos DB in the next 1 to 3 years, those are great options to just use them to actually save money on it. If you are using more than 1 million request units, that number can actually go up to 60% in some cases. So just check it out because you don't really need to do that much to actually save money with this one. Next one, this one is actually new in preview right now. You can actually do priority-based executions. So whenever you execute anything, everything is in high level right now. You can have 2 levels. So if you have a web application, maybe it's very write-heavy application. You don't want to lose all the the writes, but you have a couple of reads too. So you can easily say the reads should be low and the write transaction will be high. So just like the going in plane, there's a priority out there. The write will be always high in your case. And if something needs to fail with the 429, that will be the low transactions. So you can have some kind of control like that. This one works just like this here. So I have the item request option here. And I'm making this one, whatever I'm posting here, is priority level high. So there's a low and high. You can easily kind of control that. As I say before, this is still in preview. So this is not ready for the production, I guess, but you can really try it and give some feedback to the Cosmos DB team. I'm sure they will be happy. So this is all I have right now before I show some demo for you. But the demo I'm going to show you, I'm not sure if you already know it or not, but you can download it from there. It's a free VS Code extension that I developed. And that's my contact information. If you'd like to contact me later, I'll be more than happy to answer any of your questions. So with that, let me actually open the VS Code here. So when you open the VS Code, you can easily download it from here. If you search by my last name should come up. It's free, no charge out there. And right now, I believe I have almost 12,000 downloads on it. So many people are liking, and there's a good feedback on it. So the first thing it's going to ask you how you're going to connect it. You're going to put your connection key out there. Then it's going to list you all the databases and containers of each database. So in this case, I have the Stack Overflow here, and I pick the posts. Those talks, I talk about the physical partition and other stuff, but there's not really easy way to go to Azure portal and kind of show them on how it works. So that's the main kind of reason I started this extension. This one is going to make you easy because when you click the partitions here, for example, for this container, you can see how many physical partitions actually this one has. And you can also see these are the hash numbers of each server. So in that case, I think for the post, I believe the property post ID is my partition key. So partition key is going to get hash every time you are running or getting the data, and it's going to be between, I think this is the 0 here, and this is the FF, so it's going to be between that number. That's how Cosmos DB is going to know which database server actually has your data, and it's going to send the request there. So this one actually makes it easier for you to see what you are really dealing with before you run any kind of queries. So if I'm going to run really something simple like that, just give me select top 10 from the post. If you execute that one, so I get the data here. It tells you how much request charge for you, and you get the 10 items. But if you remember, I show you the SDK is actually the one which is filtering stuff. So you can easily go here, execution metrics, and see how many requests actually happen in the backend. I had 5 physical partitions. You see 10, but actually I got 50 documents. So SDK was the one which filtered 40 out and showed 10 to you. You can easily click on this if it's more than 1 and see how much request unit each server costed for you. So that's really for some people, it's an eye-opener because as your data is going to get larger, this problem is going to get bigger, because you're going to have more servers, and each of them is going to give you more request units. So this problem is going to get bigger if you don't have the partition key. Also, this application can give you the point read, the one that I show you. So if you pass 2 numbers here, this will actually give you the option for the point read without writing an SDK yourself. Rather than that, which I believe last month, index metrics went generally available in Cosmos DB. And you can actually see that here. You can just click this one here, and you will see a new tab, indexing metrics. So if you have any kind of query like this, so if I run this one here, this is going to actually suggest if it needs any indexes or not, and it will show you if it's using any other indexes. So as you can see, I just search by the type and the score, and it's using the type. It looks like I don't have the score, so if you actually click the indexing policy, looks like score is excluded. So you can easily see what is in your indexing policy and which indexes your query is using by using the indexing metrics here. If you do that by the SDK, you can do it with the SDK, but the only thing I don't like in the SDK, it just sends the data to you in a chunk of text. So it's not easy to figure out. You kind of need to read it manually. You cannot really categorize what is utilized, what is not utilized. So as we talk about the indexes, so in here, I have actually same data in multiple places. So if I'm going to run this one in the post tree, you can actually see what's really happening. So this one does not have the score. So if I'm going to run this here, this is only one physical partition. You will see your request unit is going to be pretty high because, well, score is not indexed. Looks like 322. So what you are really doing this, if you compare this to SQL Server, this is a table scan. That's what we are doing here. And this indexing matrix is actually showing that to you, that you are actually missing that. So it's pretty important. So if I go, for example, to post 2 here, which it is indexed out there, you will see a big difference because at the end it's a database, right? You want to be sure that everything is indexed. It went back to 9.78. So you want to be sure that all the properties you need are indexed, and if you are not using them, you exclude them, the right ones. And indexing metrics can actually help you with that a lot. So if you will have time, please, I guess get it. As I said before, it's free. It can do much more than that here. It supports all kind of stuff. So I'll be more than happy to kind of get feedback from you. And I just want to kind of share that with you. But that's all I have. Please let me know. If you have any questions, I can try to answer now or later. And thank you again for coming to my session. Thank you.